Hello again. So now we will move on to the so-called half-angle identities, and I've just written them here already for convenience. So the half-angle identities say that if you have any angle theta, you can compute the cosine of half of that angle, the cosine of theta over 2, as plus or minus, I don't know which, 1 plus the cosine of theta over 2, sine of theta over 2 is plus or minus 1 minus cosine theta over 2, tangent is sine over cosine. So, there's one ambiguity you see immediately. There's this plus or minus. The half-angle formula can't tell if these are positive or negative. And we'll see why that is in a little bit. But for now, let's move on to just how do you use these formulas. So what these formulas say is if you have an angle that you want to understand, and that angle happens to be half of an angle you do understand, then you can use these formulas. So let's do exactly that. Let's try to use the half-angle identity and the fact that the cosine of pi over 4 is the square root of 2 over 2 to compute the cosine of pi over 8. So let's do that. Let's try to compute the cosine of pi over 8, and that is the cosine of, and I'll try to add some color coding here, pi over 4 in red, all over 2. So what am I going to do? I'm going to take this formula, this formula, and I'm going to plug pi over 4 in for theta. So let's do exactly that. So that says the cosine of pi over 4 should be plus or minus, it can't tell which, the square root of 1 plus the cosine, and then stick with the color coding in red, pi over 4 all over 2. And now let's just go through and simplify that. So that's plus or minus the square root of 1 plus, what is the cosine of pi over 4? It's the square root of 2 over 2. All over 2. And on the one hand, like, there is an answer. It's not completely simplified, so we should fix that. We also will need to deal with the plus or minus sign, but maybe I'll put that off until the very end. So let's see what this is. So I see a fraction in the denominator. 1 plus square root of 2 divided by 2. So I should get a common denominator. Should we write that 1 as 1 over 2? So I get plus or minus the square root of 2 over 2 plus the square root of 2 over 2 all over 2. Equals 2 plus the square root of 2 all over 2. Big square root still, all over 2. So I just added fractions in the numerator. Well, that's division by 2 and then division by 2 again. So that's the same thing as division by 4. And now, do you see any perfect squares under that square root? You do. You see this 4. So I can pull that 4 out of the square root as a 2. I'll see plus or minus the square root of 2 plus the square root of 2 all over 2, because the square root of 4 is 2. Nice. So there's an answer, but it's not really an answer. It's two different numbers. Cosine of pi over 8 is just one number. So let's try to think about quadrants. So let's try to draw an angle of pi over 8. So let's see. Well, there's an angle of pi over 4. Pi over 8 will be half of that. So that's in quadrant 1. So that means that cosine of pi over 8 is positive. So I should make the positive choice. There's the cosine of pi over 8. And hopefully that's familiar. If you remember from a while ago, we stated what the trig functions at pi over 8 were without proof. Here is the proof. That's why the cosine of pi over 8 is equal to that. Now let's do the cosine of 9 pi over 8. And the purpose of this next example is to illustrate that that plus or minus sign really, really does matter. And so maybe I'll encourage you to do the following. Do this computation on your own, and then we'll come back. Okay, so I'm going to stop talking now. Okay, good. You did this computation, now let's just talk through it. The cosine of 9 pi over 8, well, that is the cosine of 9 pi over 4 over 2. So I will take this to be my choice of theta. And what do you get? You get that this will be plus or minus the square root of 1 plus the cosine of 9 pi over 4 over 2. So let's try to decide what quadrant this will be in. Let's deal with the plus or minus sign first, is what I'm saying. So let's try to draw an angle of 9 pi over 8. Well, let's see, that's the same thing as pi plus pi over 8. So that will be an angle of pi, and then an extra little bit, an extra little pi over 8. Not drawn to necessarily correct scale, but approximate scale. Yeah, that'll be in quadrant 3. So it looks like cosine is negative. All right, cool. So I'll need to take the negative choice because of that. So this will be negative the square root of, and now it'll be the same computation from the inside out. Just the same computation from as above. What's the cosine of 9 pi over 4? Well, drawing 9 pi over 4, maybe I'll draw it on that same unit circle. That is 8 pi over 4, so that's 2 pi, plus an extra pi over 4. So that will be full revolution, plus an extra pi over 4. That extra full revolution doesn't change trig function, so this will be the same as cosine of pi over 4, which is the square root of 2 over 2. 1 plus root 2 over 2 all over 2. And hey, this is the exact same thing as we just computed. So I'll skip the walk because I know what the answer will be. It'll be this, but I'll need to remember the negative sign. Negative the square root of 2 plus the square root of 2 all over 2. So that negative sign really matters. If you just want to know where the angle pi over 4 and 9 pi over 4 were, you wouldn't be able to distinguish them. But when you divide them by 2, you get exactly the opposite. So you really need to think about that plus or minus sign. So I guess the answer to this is yes. So let's just go through and see if this correctly predicts some things that we already know. So you already know what the cosine of pi over 6 is. It's the square root of 3 over 2. But pi over 6 is half of an angle that you know. It's half of pi over 3. So let's see if this correctly predicts this result. So what does this mean I'm going to do? I'm going to plug theta equal to pi over 3 into the half angle identity. And what will I get? Well, I'll see that the cosine of pi over 6 is the same thing as the cosine of pi over 3 over 2 will be plus or minus the square root of 1 plus the cosine of pi over 3 all over 2. And now, well, we have to simplify. And let's deal with the plus or minus first. So let's see, pi over 6 is in quadrant 1. Cosine is positive. So this will be plus the square root of 1 plus cosine of pi over 3 is 1/2 all over 2. And now I guess we have to simplify. 1 plus 1/2 is 3/2, and then I divide by 2 again. 3 divided by 2 is 3 over 4. Do you see any perfect squares under that square root? You do. You see a 4. Nice. So that correctly predicted what the result should be. And, well, you can get some other new things out of this. You can compute trig functions at pi over 12, because that's half of pi over 6. Let's compute the cosine of pi over 12. Well, that'll be the same thing as the cosine of pi over 6 over 2. Buy myself some space to draw that line. So, what does that mean? I'm going to take that in for theta, use theta equal to pi over 6 in the half angle formula. And we will get that this is plus or minus the square root of 1 plus the cosine of pi over 6 all over 2. And then we'll walk from there. Plus or minus? Well, pi over 12 is a very small angle. So we're starting at horizontal and we're rotating up by just a little bit. That'll put us in quadrant 1. So without writing anything, just thinking those thoughts, you can see this should be a positive. And now we'll replace that pi over... this was supposed to be red. I guess it doesn't really matter. But I should try to abide by my own color coding conventions. Square root of 1 plus the cosine of pi over 6, we literally just computed, to be the square root of 3 over 2, all over 2. And now we just need to walk that out. 1 plus the square root of 3 over 2, get a common denominator. That 1 will be replaced by 2 over 2. That'll give me 2 plus the square root of 3 all over 2 by getting a common denominator and adding fractions. If you need to do that in 2 steps, then do that in 2 steps. And let's keep on going. I see division by 2 and then division by 2 again. If you divide by 2 and then you divide by 2 again, that's the same thing as dividing by 4. Square root, still big square root, everything's under the square root. 2 plus root 3 all over 4. Again, we see a perfect square under that square root. And there is the cosine of pi over 12. Very good. So, I think there's one more thing that doesn't necessarily appear in the notes as is. No, let's do this. So let's finish this up, do this last page. I'm only at like the 15-minute mark, and we haven't done anything with the half-angle formulas for sine or tangent. So let's try to do that. Let's try to compute the half angles. Let's use the half angle identities to compute cosine and sine and tangent, all at 5 pi over 8. And in fact, all we really need is knowing what the cosine of 5 pi over 4 is. What is the cosine of 5 pi over 4? Let's draw a picture and remember. 1, 2, 3, 4, 5. So each of those was a pi over 4, and there are 5 of them. Cosine of 5 pi over 4 is negative root 2 over 2. May as well write down what sine is. Negative root 2 over 2. Next, well, let's look at what we actually want to compute. I want to understand what cosine, sine, and tangent of 5 pi over 8 are. And you know what? Let's go ahead and figure out what quadrant to live in for. So I'll draw a bunch of angles of pi over 8 until I've drawn 5 of them. So there's 1, 2, 3, 4, 5. So this appears to live in quadrant 2. And importantly, that was a question about 5 pi over 8, not 5 pi over 4. Therefore, this is quadrant 2. So cosine of 5 pi over 8 is negative. Sine is positive. Tangent is negative. And right, geometrically, how do you talk about tangent? Well, tangent is the slope of this line. And that line, as x goes from left to right, the y value goes down, so that has negative slope. So tangent is negative. Alternately, sine is positive, cosine is negative. So you know tangent will be positive over negative is negative. So let's try to compute these using the half angle identities. And I'll encourage you guys to go through and do it first, and then we'll come together. So you should pause the video, make these computations, and then we'll come together. All right, so you did them already. Let's talk. Cosine of 5 pi over 8 is the same thing as cosine of 5 pi over 4 over 2. So I'll take that, and that will be theta in the half angle formula. And you see, there it is. There's the half angle formula for cosine. I've plugged that value in for theta. And now let's just go through it. So this will be plus or minus the square root of 1 plus, what's the cosine of 5 pi over 4? It's negative root 2 over 2. 1 plus negative radical 2 over 2 all over 2. And then, well, we've done simplifications a lot like this quite a few times, but let's do it again. So that 1 will become a 2 over 2. Yeah, equals, let's deal with the plus or minus. Cosine, we just said it's negative. So this is negative the square root. I'll place that 1 with a 2 over 2. 2 minus the square root of 2 all over 2 all over 2. So I've just rewritten that 1 as a 2 over 2, and I've added fractions. This is equal to this negative the square root of 2 minus root 2 over 4, right? Over here I see division by 2 and then division by 2 again. That's the same as division by 4. Now I see a perfect square in that denominator, so that's negative square root 2 minus square root 2 all over 2. There is the cosine of 5 pi over 8. Next, let's compute the sine of 5 pi over 8. So that will be plus or minus the square root of, and we haven't done any sine examples yet, but we have that formula. Hasn't been that long ago. There's the half angle formula for sine. Looks the same as the half angle formula for cosine, but there's a minus in front of the cosine instead of a plus. So this will be plus or minus 1 minus cosine 5 pi over 4 over 2. So, all right, what am I going to do? This thing that is being divided by 2, not including the 2 in the denominator, plug this in for theta in half angle formula. There we go. And now let's decide between plus or minus. It says above, right here, sine is positive. So we will use the positive branch. This will become just plus, so the positive square root of 1 minus negative square root of 2 over 2 all over 2. So I notice the double negative sign because cosine of 5 pi over 4 is already negative. So it's 1 minus a negative. So it'll be 1 plus root 2 over 2, all over 2. Get a common denominator, square root 2 over 2 plus root 2 over 2 all over 2 equals the square root of, now in the numerator right here, I see a fraction plus a fraction. Those two fractions have a common denominator, so it's easy to add. You just add the numerators, get 2 plus root 2, parenthesis, parenthesis, both of those divided by 2, and then I still need to divide by 2 again, and well, we've done that computation enough times that I think you see how that's going to play out. So there's the sine of 5 pi over 8. Finally, let's compute the tangent of 5 pi over 8, and we'll do this two different ways. Maybe first we'll use the fact that we've already computed sine and cosine. This will be the sine of 5 pi over 8 divided by the cosine of 5 pi over 8. And I know what both of those are. Let's zoom out just a little bit. Sine is root 2 plus root 2 all over 2, with parentheses appropriate. Then divide by cosine, negative square root of root 2 minus root 2 all over 2. And I won't worry too much about simplifying maximally, but I will do a few things. You see that the denominator is negative, so I should just put a negative out front. The numerator and denominator are both divided by 2. Those will cancel. So I'll be left with negative root 2 plus root 2 all over root 2 minus root 2. And we're done. Finally, let's compute this one other way. I'm sorry, typo there. Still a typo. I didn't actually fix it. I just wrote it again. The tangent of 5 pi over 8 should be the same thing as the tangent of 5 pi over 4 all over 2. So, what will I do? I will plug this in. In the half angle formula. So let's see what that becomes. So that'll be plus or minus the square root of, and now we'll remind ourselves the half angle formula for tangent. Plus or minus square root 1 minus cosine divided by 1 plus cosine. All right, and first things first, remind ourselves if it's positive or negative, because we already walked that out. This angle is in quadrant 3, where tangent is negative. That's not very clear. Let's make that more clear. Negative. And now we know what cosine of this theta is. Oh, sorry, I said I would plug a thing in, and then I didn't actually plug a thing in. So that theta is 5 pi over 4. And what is the cosine of 5 pi over 4? Well, remember, it's negative square root of 2 over 2. So let's do that. So negative, because of this negative sign, big square root, 1 minus cosine of 5 pi over 4 is negative the square root of 2 over 2, divided by 1 plus negative the square root of 2 over 2, equals negative square root, minus a minus becomes a plus, So that'll be 2 over 2, get that common denominator, plus root 2 over 2, all over 1 minus root 2 over 2. So that'll be 2 over 2 minus root 2 over 2. And let's just keep on simplifying. Equals negative, because I haven't done anything with that negative sign yet, the square root of 2 plus root 2 all over 2, all over 2 minus root 2 all over 2. Right, the reason to get a common denominator is so that you can add fractions easily. Now that we've added those fractions, we see that the numerator and denominator are both divided by 2. Those two divide by 2's cancel. And we're done, we get our result. And let's just compare real quick. Yeah, that's the same as we got over there. Cool. So, that's the end of the lecture. There will be a few extra credits associated with this. You should take a look.